This is the second video for sample exam number 2 for Math 107. In the second video, we start off with a piecewise function again. So if you hadn't noticed, I think piecewise functions are really important, and so I include them all over the place. And these are just linear pieces. Okay, you see a linear because it's only t raised to the first power, or there's no t at all, meaning it's a constant. So the idea is divide your timeline up. Time is going to go all the way to 12, but divide it 0 to 4, 4 to 5, 5 to 9, 9 to 10, and then 10 to 12. And on each one of those timelines, you're going to have a different function. It might be a horizontal line, in this case at 180. Here's another horizontal line at 360. In between it are going to be not horizontal, just a slanted line. In this case, the slope is 45. In fact, they're 45 all the time because this has somebody's left end enclosure at 45 miles an hour. Maybe party A is a, I don't know, cheetah or something. Okay, how do you graph this? When you have this little piece here, evaluate it at the 0, then evaluate it at the 4. Those 2 points give you your straight line. Draw a straight line between them. Here, there's nothing to evaluate in the second because it's 180. When I go to the third line, all right, I'll give it a little highlight here so you know what I'm talking about. I do the same thing. I evaluate it at the 5, put a 5 in for t, then evaluate it at the 9, put a 9 in for t. That will give you 2 points. Draw a straight line between them. And in this is 360, so it's a horizontal line. And now again, you do the same thing here. You evaluate this function at 10 and evaluate it when t is 12. That means put a 10 in here and then go and put a 12 in here. Work out the arithmetic. That will give you 2 points, and then you draw a line between them. Now let me show you the graph. This will be a graph of the problem we just talked about plus the next one. But here I want to show you how this works. The red line is the one we just talked about. Okay, remember there were sections where it was horizontal, 180, and then 360. Here are those 2 horizontal sections. In between it, it has these lines with these slopes, all of 45. Okay, to find this, you would evaluate it at 0. Evaluate that first at 4. That would give you those 2 points, and you connect them. Those 2 evaluations in the third line will give you those 2 points, then you connect them with that straight line, and here we go for this last one. Now there's a pursuit vehicle going 60 miles an hour, but it doesn't start. This one has a 4-hour lead. So if I say t is 0, when this one starts, t would be 4. If this one has a 4-hour lead, then the pursuit vehicle started 4 hours later, but is going 60 miles an hour. You have to write the equation. Distance equals velocity times time. Right. But in this case, that time is shifted. Remember that to shift something horizontally, right, you would subtract that distance you want to shift it from the independent variable. Here the independent variable is time. So for a 4-hour lead, for the others, then the pursuit vehicle would be v times t minus 4. And the equation would only be valid for t greater than or equal to, to 4. Because the pursuit vehicle was obviously doing something else when this cheetah or whatever took off. The velocity is 60, so that's why the 60 is here. T minus 4 gives you that 4-hour shift. You only care about time greater than or equal to 4, and you need to graph this on the same equation, on the same function, with this function. So now we're looking at the same graph again. The red was the escapee. Okay, he has a 4-hour lead. You see the pursuit vehicle, which is in blue. Started 4 hours later. That's why he starts here when t equals 4. And then evaluate it at 4, evaluate at 12. It has a slope of 60 all along it, and you can draw a line, and you can figure out Where these cross is where the pursuit vehicle would intercept the escapee. Now we have some complex numbers. You're given two complex numbers and you're supposed to work out whatever the operation is. In this case, multiply. To multiply complex numbers, you FOIL them. Okay, 12 times 2 gives you the 24. Fine. 12 times 4i is 48i. You might even want to pretend the I is an x in your mind to get this right, but you can't neglect the I. Now I have 6i times 2 for the I, the inside terms, which is 12i. Here's the problematic one. I have 6i times 4i, which is 24i squared. If I had 6x times 4x, you would know that that would be 24x squared. Well, the I operates just like that. It's only a symbol. It can't be ignored. So I would have that I squared term. That's the first step in multiplying these complex numbers. The next very, very important step is to set I equal to negative 1. I squared equal to negative 1. You cannot neglect that I squared. When I set it equal to negative 1, it multiplies the 24, making it minus 24. Now collect similar terms. The similar terms are the real terms. In this case, you're going to get 0 for a real term. And then the imaginary terms, 48i plus 12i, that gives me 60i. That's my answer. It is a complex number. The real part is 0. That's a valid answer for a real part. The imaginary part is 60i. For this one, you need to multiply a complex number by its complex conjugate. So you have to know what complex conjugate is. Right? Complex conjugate has this value the same, the real value, and the imaginary value is, well, you can think of it as the same with this plus sign changed to a minus, or you could say it is the negative of what it was before. So if I have 3 plus I, its complex conjugate is 3 minus I. If I had 2 minus 6i, the complex conjugate would be 2 plus 6i. So you have to know what complex conjugate means. Now once you have it, you multiply them together. So you have 9, and then minus 3i plus 3i. Last term is negative I squared. Don't forget, just because you have a 1 in front doesn't mean the I goes away. So that's negative I squared. The cross terms cancel, right? And setting the I squared equal to minus 1, you get 10. Because this becomes plus 1. Remember, there's an invisible 1 right here before the I squared. So when I set I squared equal to minus 1, it changes that sign, and now it's 10. That's the answer of multiplying this term, 3 plus I, by its complex conjugate. In the next problem, you simplify it. You can say it's simplified. This is, as you know, what passes for division by complex numbers. You look at the denominator and you construct its complex conjugate and you multiply that. Remember, 2i by itself is really 0 plus 2i, so its complex conjugate is 0 minus 2i, and that's where I got this value right here. Multiply numerator and denominator by minus 2i. You have to carry out this multiplication. In this case, it's not too hard, and you get 4. Why? Because you have minus 2 times 2, which would be negative 4, times I squared. That's a negative 1 in its own, and that gives you the 4. Here you have to distribute through. So I have minus 6i minus 12i squared. But what's I squared? I squared is negative 1. Again, you can replace that by negative 1, changing the sign of the 12. I'll put it in front, 12 minus 6i divided by 4. And then you should carry out, if you can't carry out the division, at least put it like this. 12 over 4 minus 6 over 4i, so that you have real and imaginary parts separated. Don't leave a complex number over a denominator like that. Now you have to add two complex numbers. Easy enough. The real part is 0. That's all you have to remember there. So the 4 and the 0 just keeps the 4. Then you have 12i minus 3i is 9i. This has to do with the powers of I, and they're listed here. And these are something you have to know. I by itself is the square root of negative 1. I squared is negative 1 because you square both sides and the square root goes away. I cubed is minus I, and I to the 4th is 1. So if you have something with higher power, you divide by 4. That will give you the number of I to the 4th that you have, but those are 1, so they sort of vanish out of the problem. Alright, they turn into 1s. And then the remainder, okay, let's do one with a remainder. Let's say we have 15, I to the 15. Take the 15, divide by 4, and I get 3 with a remainder of 3. That's an R, but it turned into a B somehow. Okay, so that means I to the 15th equals I to the 4th cubed times I to the 3rd. Would this work? Yes. If I multiply this out, 3 times 4, exponent on exponent, you multiply. So this is I to the 12th times I cubed. Now you would add those, the 12 and 3, and get 15. Fine. But I to the 4th is 1, so this is just 1 cubed, which is just 1. And then I have I cubed. So I to the 15th is the same as I cubed. And you know what that is? That's minus I.